Okay, so one of the common mistakes I see is that students often will confuse p-value for proportion when they're looking at their calculators. Don't confuse them, please. One's the probability of finding whatever you're looking for, and p-value is the probability of getting a test statistic. So while they both stand for probabilities, they both represent two very different things. Okay, so next thing we want to do is discuss errors. Now, every single problem we do has four possibilities, and there's a probability of each. There is, so we could either reject the null hypothesis or we can fail to reject null hypothesis. Those are the two we've been talking about so far. The two other ones that could come up are basically errors. There's what's the probability of this error happening. The first one that we are familiar with right now is alpha. This is the technical definition now. I haven't discussed that quite yet. I've been waiting to the end to give you a full definition. Type 1 error, also known as alpha, is when we reject the null hypothesis when we shouldn't have. It's actually true. The null hypothesis is actually true. This is the worst of the two situations. This is why we want alpha to be small. The other one, which is number 4 on our bullet points here, is we fail to reject the null hypothesis when it's false. This is the lesser of the two errors. This would be incorrect, and we call it type 2 error or beta. We will not calculate these at all. Alpha will be given to us. Beta would be given to us. These are things you would do in a future course. Now, I definitely want to go into why alpha is worse. Oh, wait, before I do, you need to know that the relationship between alpha, this is the only thing you need to know mathematically about alpha and beta. If alpha increases, beta decreases. If beta decreases, alpha increases. So it just has an inverse relationship. As one increases, the other decreases. All right, so here's the last thing. Alpha is worse because, let me give you an example of a schizophrenia drug. So let's just say we are going to reject the null hypothesis and say that this schizophrenia drug works. Type 1 error says we did that incorrectly. So basically what we're saying is like this drug that we just came up with schizophrenia worked for our sample, but it does not actually work. It just happened to for whatever weird reason. But now it's going to go distributed to the public, and it's causing actually worse issues than it's solving for schizophrenia. That's why you see a lot of times like these errors coming up with mesothelioma, where it comes up with cancer or even a likelihood of death. Type 1 error is very, very serious. That's why we consider type 1 error more than we consider type 2 error. Because type 2 error in that same situation would be, it's a way of saying, well, here is our drug, we tested it with our group, and it didn't work with that group. So therefore the drug doesn't go on to mass production. But if it would have gone on to mass production, it would have worked, it would have helped people. So what is the worst of the two? Definitely alpha. Because that can directly affect people's health, causing terminal illness. It could cause many, many, many bad things. Like saying this thing is safe, doing a test and saying, hey, this new invention is safe, when it really isn't. So that's why we want to keep type 1 error as small as we possibly can. And that's why that's extremely important to know. Now, for your homework, all you're going to be doing is you're going to be identifying what type 1 and type 2 are in terms of the problem. So here's our example. Consider the claim that the medical drugs is helping the schizophrenia, so that it probably the drug is successful at 0.35. Here are the alternative hypothesis. We just discussed that. Now, what I do want to bring up is if you pull up my slides down here, I have a link to actual lawsuits where this isn't what happens when you don't consider alpha the way you should. This is why multiple tests need to be done. Especially right now is a perfect time to explain why this is important, because with the coronavirus, yes, we have these two drugs that Dr. Fauci has come out with. He says, yes, these right now need to be done in clinical trials with randomized. This is why this is so important. He says we don't want to give out a quote unquote cure or a way of treating the symptoms, but the symptoms are worse than the drug was intended to do. So while it may cure coronavirus or get rid of coronavirus, it causes liver atrophy, dysfunction. It causes the liver to cancel, just stop working, or the kidneys stop working. Those would be negative side effects. So that's why these tests need to be done in randomized trials to make sure that our alpha is truly as small as possible. We're not saying this thing is not going to actually cure it or whatever or what have you. So please go ahead and look at this lawsuit. It's a very interesting article to read. If you have questions, know that I'm always on my office hour. Here's your homework. Please combine it all into one Google assignment. I have reduced it for you. It's just more practice on hypothesis testing. I don't care what method you use. If you're comfortable with the critical value method, use the critical value method. If you like the p-value method, use the p-value method. At the end of the day, it's what you understand, what you want to work with best. Now, just please realize that typically when we're discussing with other colleagues and peers and other researchers, they're going to use a p-value typically to help explain their results. So once again, if you have any questions, I'm here, and I'll do the best I can to help you all out.